Now let's look at what happens when you have a workload with a large number of jobs and its behavior over time. So suppose that I have a very large workload of, say, 1 million jobs, and I'm going to give it to a batch system to execute. There's a very common behavior that we'll often see if we look at the behavior of the batch system over time. So I'm going to put time on the x-axis here and number of jobs running. Now, there's 1 million jobs that I need to run, but let's say for the sake of argument I have 1,000 CPUs to run them on. So we can put up here the maximum number of jobs that will ever be running simultaneously is going to be 1,000, because that's simply how many machines I have. Now, if I give a large number of jobs to a batch system, we're going to see behavior that's similar to the following. At the beginning, we give a large number of jobs to the batch system, and it starts to dispatch them one by one to each node of the cluster. And so those jobs start running over time. But I can't start every single job simultaneously, and so it takes a little while to get all of them going. So we'll often see, it may be steep, but there will be a curve by which it takes time for me to get all of those jobs running. Now eventually the batch system gets all of those nodes running, everything busy. And then as each job completes, we might see a little downtick here until where the batch system is able to dispatch another job, and then it goes up. So we might see a little wiggle here that relates to the ability of the batch system to start and stop individual jobs. Now this will go on for a while until we start to get to the end of our workload of 1 million jobs. Now you might expect that we get to the end of the workload and suddenly everything stops, but that's not what actually happens in practice. Instead, what we see is a behavior that looks sort of like this. And this behavior is known as the long tail. Now, why does this happen? Ideally, each one of our 1 million jobs would take exactly the same amount of time. And so if we started them all at exactly the same time, they'd all finish at exactly the same time. But it turns out that in any system of sufficient size, there's a large amount of noise. As you've seen already, it took some time for those jobs to start because they each had to be dispatched and the files had to be transferred out, and they might have to wait in a queue behind some other jobs. But then the jobs don't all take the same amount of time, even though we might want them to. The jobs themselves might vary. If you're running 1 million simulations with different parameters, they're not all going to do exactly the same thing and therefore take exactly the same amount of time. If we're going to run on 1,000 machines, even though those machines might appear identical, they're not going to give identical performance. They might have slightly different hardware. They might have a different amount of memory. They might have different operating system installed. There might be other things running on those machines which are going to slow the jobs down. Finally, when those jobs are done, they have to transfer their output back. And that transfer takes time as well. And not all the transfers will go simultaneously. And so the jobs will end up being staggered as they come back. So throughout the lifetime of a workload, the jobs become somewhat unsynchronized. And by the time we get to the end, we have fewer and fewer jobs left, until often you'll see just 1 or 2 at that very end hanging on to the very end. Now, that could be it's the very slowest machine. It could also be because there's a job that ran earlier but got preempted, and now it's just starting as everybody's finishing. And so there's always something left at the end. Now, you see this in almost every system. I'm not picking on any particular piece of software. No matter what sort of distributed system you use, you will see the long tail in some way. Now, is there anything we can do about it? Well, there are some things. We can't prevent it from happening, but there are some ways that we can accommodate the long tail if we get tired of waiting. One thing that we can do is we can divide up our work into smaller units. If each of our jobs is smaller, then the long tail will still be there, but its effect is much reduced because each individual unit can be packed in much easier. Another trick we can do, now you can't always divide into small units, but another trick you can do is when you get to the end and you have some idle CPUs, you could take some of these jobs that are taking a long time and run multiple copies of them. Now this helps with the long tail because when you run multiple copies, you can use all the available CPUs, and then whichever job happens to finish first, you take that job as the result, and then you kill off the other job. So we can do that. And if we apply either of these techniques, you might see something more like that. Now either way, you can't get rid of the long tail. It's simply a feature that you have to live with in the design of any distributed system.